Hey everybody, Marcus here. I know I talk a lot on the channel about kilowatt hours, solar production, house usage, and a lot of other big terms, but for somebody that's not an electrical engineer like myself, sometimes it can just make my eyes gloss over it, go right over my head. So today's video is going to be about putting it all into perspective. What are your solar panels producing, and how does that relate to what you use in your house? I'm going to take a look at things we commonly use in the house, what their power draw is, and how that relates to what you're producing or storing in your batteries. Keep on watching. Now we have to look at two formulas to put power and energy into perspective. Power is the amount of work an electrical current can do, and it's represented by the formula P equals V times I, where P equals power measured in watts, which is equal to voltage, V, times I, which is current measured in amps. If we were to look at a normal household outlet, 15 amps at 120 volts is 1800 watts. But when you're using larger sums of power, it's sometimes seen as kilowatts, kilo, so you divide by 1,000, which would be 1.8 kilowatt. Now, energy is the sum of power over a period of time. Quite simply, it's a way to measure the capacity of something like a battery. Now, normally that period of time is over an hour. So if you look at that previous example, 1800 watts over 1 hour would be 1800 watt hours, or using kilowatts, it would be 1.8 kilowatt hour. Now, if you look at a Powerwall to put it into perspective, its capacity is 13.5 kilowatt hours, or 13,500 watt hours. If you were to run that outlet continuously at the 1800 watts, that Powerwall would last for 7.5 hours. Here's the fun part. I went around the house and looked at things that we use every day and wanted to bring that back into perspective of how much electricity it uses, how much, power it draws and energy it consumes, and then to loop that back around into what our solar produces and what we use every day. So, say you wake up in the morning and you take a shower and you need to dry your hair. Now, I don't have this problem, but my wife uses a hairdryer. We have one of those Dyson hair dryers. That uses 1600 watts, which is roughly 13 amps at 120 volts. If she uses that for 20 minutes, let's say, that's roughly 500 watt hours, or a half kilowatt hour. Now, putting that into perspective, we drive electric vehicles, and our electric vehicles typically get about 4 miles per kilowatt hour, which is 250 watt hours per mile. Basically, what I'm saying is that you using that hairdryer for 20 minutes, or 500 watt hours is the equivalent of driving your car 2 miles. Just goes to show you how efficient electric vehicles can be, but at the same time, how inefficient using something like resistive heating in a hairdryer is to produce heat. Basically taking that electrical current and just making heat from it. It's very inefficient, but it's also very effective. My morning routine is to go out and make coffee right away. So looking at our coffee maker, it's roughly 1300 watts of power that it uses, which is 10.8 amps. Now it's only running for about 5 minutes or so to make the coffee, so it's probably only consuming about 100 watt hours or 0.1 kilowatt hours of energy. I'd also say, make toast, which our toaster uses 780 watts. It's only on for 2 or 3 minutes or so, so it's probably only using about 50 watt hours worth of electricity. It's only about 150 watt hours, 0.15 kilowatt hours of energy consumed. Now, say I wanted to make something like chicken nuggets for lunch. Our air fryer uses a lot more power, but it's a lot more efficient also than using, say, the stove or the oven. Basically, the air fryer draws 1700 watts, or 14 amps at 120 volts. Now, there's one thing to be said about something like using an air fryer, and that you may notice that using other items on that same circuit will cause the breaker to trip. And that's because electrical code calls for a continuous load to only be 80% of what a circuit's rated for. So despite that air fryer being on a 15 amp outlet, it's pulsing on and off and on and off. So that's why you can use it without tripping the breaker. But if you add, say, a coffee pot or, in another George Foreman grill or something, it's probably going to trip that breaker because there's too much draw on that circuit. Now, running that air fryer for 15 minutes at 1700 watts is going to be 400, 500 watt hours. So again, about a half kilowatt hour. So it's one of those larger consuming energy devices in your kitchen. Now you're all finished with your breakfast and you stick the plate and your cup into the dishwasher and start it up. Our dishwasher runs for about 2 or 3 hours at a time using the sanitized cycle, and it draws 924 watts, 7.7 amps at 120 volts. Now it's not going to be at that peak power the entire time, but running over 3 hours, it's going to consume about 2 kilowatt hours worth of electricity. Compare that though to what it would take to heat all the water and all that to wash it by hand. So dishwashers can be, a higher consuming appliance in the kitchen, but at the same time, they're really not consuming that much for the amount of work that they're completing. So far, I've only talked about things that are kind of intermittently used throughout the day, but there are also things in our house that are running continuously. One of those things would be an air purifier, like in the background there, and that consumes 45 watts of power. Now, with that running 24 hours a day, it basically consumes 1 kilowatt hour itself per day. We have a couple of those around the house, so that can add up depending on how many of those you have. We also have 2 fridges in our house. Now, one is considerably older than the other, and the first one uses about 975 watts of power, but the second one only uses about 360 watts of power. The difference being with fridges, though, is that they're running compressors, which aren't always going to be on and cooling the whole day. So let's just guesstimate and say it runs 25% of the day. If you're adding up the 2 usages there, they're at about 1.25 kilowatt or 1250 watts. Say they're running for 6 hours a day, that's 6 to 7 kilowatt hours that you'll use no matter what all the time. So when you think about what your solar capacity needs to be, you need to think about these continuous loads that are running all the time. That can also be computers that are on, maybe Alexas that you have plugged in that aren't drawing that much power, but over 24 hours, it adds up. Now, I don't know about you, but when I was younger, my parents always told me to turn the lights off whenever I was finished in an area, and that was back when we only had incandescent bulbs. Now, a typical incandescent bulb is about 60 watts versus what we have in LED bulbs now, which are 6 watts for that same amount of light. Now, think about that in terms of kilowatt hours. If you run a 60 watt bulb for an hour, that's 60 watt hours. So you can run essentially 16 60 watt incandescent bulbs for an hour and it will consume 1 kilowatt hour. Now, using those 10 times more efficient LED bulbs, you can run 160 LED bulbs for an hour and consume that same kilowatt hour of electricity. You can see why our parents always were yelling at us to turn off the lights when they were incandescent, but it's one of those things that's maybe fallen by the wayside. It's just kind of a force of habit. Hey, turn the lights off, but it's not as important these days as LED bulbs are 10 times more efficient than those incandescent bulbs are. Now, say it's summertime, and now you're going to use the air conditioning, which is going to be a much larger power draw than just about anything else in the house other than electric vehicles. Basically, let's look at our AC unit, which is about 4 kilowatt of power draw. So, in a typical summer, if it's running a lot, it's probably going to be on for 6, 7, 8 hours a day cooling the house while it's sunny and 100 degrees out. So 8 times 4 is 32 kilowatt hours, and that's where looking at a coffee maker or something else which draws a lot for a little bit, a AC unit will run a lot longer and use a lot more power for that lot longer period and consume a lot more energy. So that's why your parents were always yelling at you to close the door behind you, don't let the cold air out, because that can add up quickly. 32 kilowatt hours in perspective here. We're paying PG&E 50 cents per kilowatt hour roughly. That's $16 a day just to cool your house. Now, multiply that by 30 for a month, and that's $480 just to run your AC alone, nothing else, for 1 month. That's why it's so important to make sure your filters are clean, your system's running as efficiently as possible, that you have all your windows and doors and everything closed, no leaks, so that your AC runs as little as possible. I just talked about AC, which is a high power, high energy consuming item in a household, but thankfully it's only running during a couple months of the summer, hopefully. But we're also a 2 EV household, so we have a, higher kind of baseline electrical consumption throughout the year than, say, somebody who is driving a gas vehicle. Now, as you can see here, we use about 300 kilowatt hours in a normal month per vehicle, 600 kilowatt hours for both of them. We drive about 1,000 miles per month, and our vehicles get about 250 watt hours per mile, or 3 to 4 miles per kilowatt hour. Now that's pretty efficient. If you're using something like a Cybertruck, it's completely normal to get about 2 miles per kilowatt hour, or 500 watt hours per mile. Now, why am I bringing this up? Because when you think about production for your solar system, we have a 12.24 kilowatt array, but in December, we're only producing around 500 kilowatt hours. So we're actually, just with the cars charging alone, are going to use more than what our solar is producing during the winter. Now, take that and look at summer, and a month like July, where we're producing over 2,000 kilowatt hours, we're going to be producing in much, much greater quantities, and that number doesn't really matter. But this just highlights the importance of net energy metering, and if you have that with your system, it's of great financial benefit to you. Basically, in those lower producing months where you're not producing as much, you use the grid as your battery and use those credits that you've banked during the summer. And that's why I say it's so important to use the grid as a battery sometimes when it's convenient, because your system's just not going to produce enough in those low production months. What's the big picture with all this? So I'm kind of looking at usage in all this because I think it's one of those vital pieces of information that you're going to need to know before you get a solar panel, solar roof, or Powerwall system installed. If you know what your usage is, you're going to know better how to size your system. Now, I'd always recommend getting as much as the utility will let you allow in terms of panels on the roof. You're always going to want to overproduce, just in case, say, you get a Cybertruck or a bigger vehicle, and that way you're not going to end up paying the electric company while you're paying a solar loan, etc., because your use is more. Or say if you have gas appliances like a furnace or water heater, and you want to switch those to electric once you see the vertical integration and how awesome it is. So I'd always recommend getting more panels than or the most that you possibly can, basically. Now, if you look at your usage, May through August or so is probably going to be about 50 to 60% of your use. So this isn't an exact calculation, but I'd say if you look at your usage and your bill histories when you're looking at sizing a system, you want to make sure that what your system is producing a year, and Tesla will tell you, what you're producing, you want to make sure that it is at least twice that number for May to August. I think you should always be going for exporting, not a ton, because it's not lucrative to export kilowatt hours to the grid. And also, like, PG&E limits our exports because of the duck curve and some other items. But basically, you want to make sure that at the end of the year, when you have your true up, you're not going to be paying them at that 50 cents per kilowatt hour, rate, and that you're going to be getting money back. I think that ultimately knowledge is power here, and knowing your energy use and looking at that in regards to a system just helps you make a better informed decision. You can look at it like, hey, what's using the most electricity in my house? What's the most inefficient? What can I unplug that maybe doesn't need to be plugged in all the time? Or, hey, look at the fridge that we have that consumes almost a kilowatt of power versus the one in the garage that consumes a third of that. Is it time to get rid of that inefficient appliance? Is it finally worth it? Are you spending a lot of money for something that's older that just works but maybe could be replaced by something more efficient? Just up to you, but again, knowledge is power. So I hope you found this helpful in terms of looking at your usage and how to maybe more accurately, size up your solar panel system. If you have any questions, let me know. I'm happy to answer anything that you have. As always, if you need a referral link, I'll link it down below to get $500 off your Tesla solar panel, roof, or Powerwall system. And we'll see you next time. Have a good one.